We're located in Tourist Boulevard, right next to Redondo Beach. Today we're going to talk about a series and its convergence and divergence, and prove if it is convergence and divergence through many ways of theorems and laws. So the given series is, I put this function an 1 over n to the 4th plus 5, I named this an, and let's jump into nth term. In nth term, we say as limit of n approaches infinity, if this function does not equal to 0, it is divergent. And what does it mean by divergent? Divergent means the function, the series, the value doesn't have, only has an infinite value, not a finite value. Then in vice versa, if the series has a value of finite value, it will be convergent. So if it does not equal to 0, it is divergent. However, do not get confused. If it is equal to 0, that doesn't mean that it is always convergent. If it is equal to 0, it can be divergent and it can be convergent. And if that comes out, you have to use other ways or theorems to solve this question or problem. So let's start with nth term. Alright, limit n approaches to infinity 1 over n 4th plus 5. As you can see, if I plug in infinity to n, it will be n to the 4th. Not n. Infinity to the 4th. If it is infinity times infinity times infinity times infinity, obviously it is infinity. Plus 5, still infinity. So 1 over infinity will be 0, right? 1 over infinity will be 0. So, through the nth term, we conclude that this equal to 0. Like I said, it's not always convergence. It can be divergence too. So we don't know yet. So let's jump to P series. P series state that when n has a power and that power p is greater than 1, it will be convergence, and if it is less than or equal to 1, it will be divergence. So it's easier to look at the highest power of upper and down. So the numerator and the denominator, sorry. So in here, so I'll write it down, 1 over n 4th plus 5. I'll write a new equation right here. So the highest power will be what? 1, right? The highest power. And the lowest power here will be, at the bottom, the highest power will be 4, right? So n to the 4th. It will be way easier for you. So we created one equation, and now the answer became obvious. Because it's n to the 4th, n to the something, p equals to 4. So p equals to 4. And now, p is greater than 1. Convergence. So we have proved through P series test, we have proved that this is convergence. So let's check if P series is correct by using other tests. So today I'm going to use the direct comparison test. So direct comparison test states, in direct comparison test, there will be two series given, an and bn. And if those two are greater than 0, and if for all n values, okay, an is less than or equal to bn, then it will be convergent. And then if an is convergent, then bn is convergent. If an is divergent, then bn is divergent. And vice versa, obviously. If bn is convergent, then an will be convergent. And if bn is divergent, then an will be divergent. So, and by doing P series and looking at the highest power top and the bottom, we got out a question. The equation of another series, 1 over n to the 4th. So we can name this as an as 1 over n to the 4th plus 5, and bn as what we just solved, n to the 4th. And now, I will write bn bigger. And now, we have to first prove that these two are greater than or equal to 0. So just do not plug in 0. I mean, this will work, but not this. So plug in any number. Let's see. If we plug in, for example, 2. 2, it will be 1 over 16 plus 5 and 1 over 16. It's greater than 0. I will plug in, let's say, 3. 3 times 3, 3 times 3, 91, 98, 89, sorry. 86, and now this will be 81. Because 3 times 3 is 9, and 3 times 3 is 9. That's why. So we have proved that this is true for this equation and the Bn. So this is true. Now we have to find out if this is true. So this will be, because this is already, we write this, because 16 plus 5 is 21, it will be 21. So 21 in fraction, obviously, if the bottom number is bigger, it is smaller. Bottom number bigger, smaller. We have proved that. This is also true. Then we can prove, now we can say if Bn is convergent, then now we can say the direct comparison test works. So that means, in other words, if Bn is convergent, An will be convergent. If Bn is divergent, An will be divergent. And before I step into a step further, I will say if this does not work, if this function does not work, if this becomes false or this becomes false, then you have to use other tests. Because that means the direct comparison test does not work for this equation. So let's step further. We have to know if An is convergent, right? That means, like I said, because this comparison works, for An to be convergent, Bn must be convergent. And we said 1 over n to the 4th is Bn, right? And we have proved that through the P series, Bn is convergent. So because for P greater than 1. So this will equal to convergent. Because P is greater than 1, like I said. And because Bn is convergent, that means An is also convergent. So thank you for watching, and I hope this video was helpful.